Hello and welcome to this lesson on vectors. So just to begin, a bit about me. My name is Ritik. I'm a senior at Los Altos High School, and my favorite subjects are math, computer science, and chemistry. So to begin, let's talk a bit about what vectors are. Vectors are something that's important in both math and physics, and to put it simply, vectors are something that has both a direction and a magnitude. So for example, when we talk about cars, for example, we always know that whenever they're driving or whenever they're always moving at a certain speed. So for example, 40 miles per hour, and also in a direction. So for example, you might be going south or north or northeast. And that's basically what a vector is. It has both a magnitude, which in this case is 40 miles per hour, and a direction, in this case it'll be north or northeast. And on the bottom, you can also see how you may represent a vector graphically. So on a graph, what you could do is simply draw out the magnitude. So for example, in this case, if it's 40, you would draw 40 units and in the direction that it's going. So in this case, northeast. Now, there are different ways you can represent vectors. So whenever you're writing it out, the first way is, as you can see up here, is this xi plus yj notation. And what that's doing is basically separating the vector into its different components. So for example, here you'll see for the x component, you'll have an I to represent that, and for the y component, you'll have a j to represent that. So for example, one vector you could write out is 3i plus 5j. And when you're graphing it, what that means is that you'll draw out 3 units to the right and then 5 units up, and your vector will basically connect those points. So you'll see on the right, here's a graphical visualization of that. Then the next way is by using these angular brackets, and inside, instead of having an I and a j, you simply put in the x component and the y component. So here, for example, you can just put the angular brackets and then 3 for the x component, then a comma, and then 5 for the y component. And then on the graph, again, you would simply move 3 units to the right, 5 units up, and then connect those 2 points. And this line is the vector. And whenever you're drawing out a vector, you always want to have an arrow at the point where it stops, just to represent that it's a vector and not a line segment. Finally, in different problems, it may just give you the magnitude and the angle. Now, in this case, it's a bit more tricky because the magnitude essentially tells you the overall vector quantity, but it doesn't really tell you the x component and the y component. However, if you see on the right, whenever we're drawing out a vector like this using the x component and the y component, we always end up with a right triangle. And in this case, the angle, so like for example, in this case, the 59 degrees, is always one of the angles in our right triangle. And so if you wanted to draw this example out, you could always use trigonometry. So in this case, if you know that's going 5.83 units, the total magnitude is that, you can use sine and cosine to figure out what the magnitude is for the x component and the y component. So here, if you know the angle between the horizontal and the vector's direction is 59 degrees, you can use cosine of 59 degrees in this case would be x over 5.83. And so you can solve for x by simply doing cosine of 59 degrees times 5.83. and that'll give you the x component. So in this case, it'll be 3. And then similarly, you can find the y component by doing the same thing, except for sine. So you can do sine of 59 degrees times 5.83. And that should give you 3 units for x and 5 units for y. And so when you're graphing it out, all you need to do is, again, move 3 units to the right and 5 units up and connect the dots. Now, vectors can also be used algebraically, so whether it be adding, subtracting, or multiplying vectors. And for adding vectors and subtracting vectors, it's pretty simple. All you need to do is add and subtract the vectors for each component. And so, for example, if you see for the adding vectors, for if you were to add the vector a comma b plus c comma d, the resultant vector, its x component will just be a plus c, and its y component will just be b plus d. And for subtracting vectors, it'll be the same thing. Instead of a plus c, it'll be a minus c, and for a y component, it'll be b minus d. Now, you can also multiply vectors by a scalar. And in this case, a scalar is just a regular number. So, for example, if you were multiplying a constant by a vector, you would do it, again, component by component. And to your resultant vector, its x component will just be k times a, and its y component will just be k times b. Now, if you are given vectors graphically and you want to add them or subtract them that way, the best way of doing it is what's called the head to tail method, or it's also called the triangle method. So for example, let's say you were given these two vectors, u, which is right here, and v, which is right here. Now, the way you'd want to add these two, if you were just given the graphs and not its components or angles or magnitudes, what you could do is simply place the u vector wherever you want, and then put the v vector, place it so that its tail, or where it started from, is located right on the point where the u vector ends. And so here's how it looked graphically. You'll see that the reason why they call it the head to tail method is because the top of the u vector is touching the v vector at its tail. And when you add the two vectors, you simply draw the vector that starts from the tail of the u vector to the head of the v vector, and that'll be the resultant vector. So that's pretty simple. If you're given it graphically, you just can move the v vector so that this method works, and then all you have to do is just draw the resultant vector. And if we're subtracting vectors graphically, it's pretty much the same. And the concept is that this time what you want to do is make sure that basically the direction of the vector is being subtracted. So in this case, if you have u minus v, this is the same thing, just u plus negative v. So for example, if this is v, you can just rotate it so that it's now negative. And then if you use the head to tail method, you can find the resultant vector that way. Now, finally, one concept that I'd like to bring up that is heavily used in future subjects like physics and calculus is the dot product. And for now, don't worry too much about what the dot product actually is, but just think of it as another way of doing vector algebra. So one question they might ask you is what's a dot b? And what that means is that you're using the dot product with the vector a and the vector b, And this time, instead of other forms of vector algebra, you'll actually get a scalar quantity instead of a vector. So the way you do this is simply by multiplying the x component of A with the x component of B, and adding that with the y component of A times the the y component of B. And so here's an example. If you have the vector 4i plus 3j, and the dot product of that with the vector 2i plus 6j, you'll simply multiply the 4 and the 2 and add the 3 times the 8. So it'll be 4 times 2, which is 8, plus 3 times 6, which is 18, and that gives you 26, of course. So now that we've covered most of what vectors are about and an introduction to them, here are a few practice problems that you can do. So the first one is draw the vector that has length 5 in the direction 45 degrees north of east, and you can use that using trigonometry. And then the other three are computational problems involving vector algebra. And so pause the screen and I'll advance to the next slide, which has the answers. So 3, 2, 1. And here are the answers. So for the first problem, where we had the 45 degrees north of east and the length 5, what you want to do is use sine and cosine to get the x and the y. So for the x component, it'll be, as we mentioned before, 5 times the cosine of 45 degrees. And so in this case, it'll be around 3.58. And so you can just move 3.58 units to the right. And then for the y component, you do the same thing except with sine. So it'll be 5 times the sine of 45 degrees, which would also be 35.83 degrees, 3.583 units. And so you move that many units up. And then our resultant vector is just connecting where you started from and where you ended. And so it should look like this. Then for 2 and 3, for 2 you simply just add its component by component. And for 3, again, you multiply the constant by each component. And then for the fourth one, the dot product, again, is taking the sum of each component, the product of each component. So for the x component, it's 2 times 5, and for the y component, it'll be 4 times 4. And when you add them up, you should get 26. That'll be it for this episode. Thank you all so much for watching. Here are links to Project Slam's website and social media pages, and I'll see you next time. Goodbye.